Welcome. This is some atoms practice. Make sure you have your reference table, open the periodic table, possibly table O, and also perhaps a calculator. Which phrase describes the charge and mass of a neutron? So on table O, you see that the top number is a 1 and the bottom number is a 0, which means a mass of 1 and a charge of, well, none. So neutron, no charge, so get rid of that. And it has a mass of 1, so choice D. What is the net or overall charge of an ion that has 11 protons, 10 electrons, and 12 neutrons? So get rid of neutrons because they are neutral, no charge. So 11 positive and 10 negative. So one more positive, so choice A. The discovery of electron is a subatomic particle as a result of, this is J.J. Thomson. So nope. So those are out. So gold foil or cathode ray. Gold foil, that is Ernest Rutherford. You can obviously read that. So choice D, that is J.J. Thomson, the cathode ray tube. Which subatomic particles each have a mass of approximately 1 U? Remember, U is another way of saying AMU, atomic mass unit. So let's quickly go to here. So we see the masses. So masses of 1 would be neutron and proton, and that's it. So back to this. Mass of 1 proton and neutron. Mass, this is 1, electron is mass of 0, which is really 1 over 1836, and positron is same mass. Which has a charge of -2. So that would mean 2 more electrons than protons. So all of that, we don't care about this because this is neutrons and that's neutral. So who has 2 more negative electrons than positive protons? It would be choice A. Choice A is +8 -10, so -2 overall. Mass of a proton, which is 1 AMU, is approximately equal to what? Electron? Nope, that's a mass of 0. Neutron, that's our choice. Alpha is a mass of 4 and beta is a mass of 0. Again, don't believe me, reference table O right here. The mass is, mass is up top, protons go down here. Back to this. No, this. Okay. Which describes the charge and location of an electron. Electron is a negative charge located outside the nucleus. Choice C. What is the order of historical development from earliest to most recent? So the Democritus, John Dalton was the hard indivisible sphere, so we want B first. Then we have mostly empty space. Then we have the Bohr shell. So B, C, A. Choice C. The location of protons and neutrons in an atom of helium. Protons and neutrons are in the nucleus. Yeah, that's easy. Which particle has the least mass? Again, reference table O. Mass of 1, mass of 0, mass of 1. No, this is mass of 1. Helium has a mass of 4. Whoops. So, yeah. So, it is B. See, I should have looked at the reference table. On periodic table, the number of protons is indicated by atomic number. Every chlorine atom has 7 electrons. No, it has 17 electrons. 17 neutrons. No, I know hold on. I should have gotten rid of that. 17 neutrons? Well, let's see. 35 minus 17. Carry this. 8. Nope. A mass number of 35. No, they can change because of isotopes. Atomic number, that's protons. That's the identity. Has to be that one. The weighted average of the atomic masses of the naturally occurring isotopes of an element is atomic mass. That's why you have all those decimal places. Another one about least mass. Mass of 4, mass of 0, mass of 1, mass of 1. Reference table O. As a result of the gold foil experiment, it was concluded that an atom, no, it did not know this. All it figured out was small dense nucleus. Also empty space, but that's not written here. No. Hard indivisible sphere, nope, that was Democritus and John Dalton. Gold foil experiment led to the conclusion that each atom in the foil was composed of mostly empty space, because if it's mostly empty space, that's why they go straight through. Yeah. If two atoms are isotopes of the same element, the atoms must have the same number of protons. I agree, because they're the same element. But if they're isotopes, they must have different number of neutrons. Which two notations represent isotopes of the same element? So again, you can't have different, that gets rid of everything. You have to have the same number of protons, but different mass. So same bottom number, different top number. So choice A. Which are nuclei of the same element? So if they're the same element, they have the same number of protons. So those all have 1. So D, E, and Q. Choice B. Which numerical setup can be used to calculate average atomic mass of gallium? So percent abundance times atomic mass plus percent abundance times atomic mass. But we're going to take these and make them decimals. So that would be, instead of 60.11%, it's going to be 0.6011. Okay, so they did not divide this by 100. So now we say 0.6011 times 68.9. Yeah, it's choice A. How do the energy and the most probable location of an electron in the third shell compared to the energy and most probable location of an electron in the first shell? So higher energy, further away. So if you're also in the third shell, you're further from the nucleus. Choice B. An electron in a sodium atom gains enough energy to move from second to third shell. Okay, so if you're moving electrons, you're not changing, you're not losing or gaining. So you would be an atom in the excited state as we jump shells. The Bohr shell diagram for neutral atoms of sodium is, okay, so sodium's nucleus is 11 protons and 12 neutrons. Oh, they all have that. So, okay, so if there's 11 protons, there's 11 electrons because they're all neutral. So 2 in the first, 8 in the second, and 1 in the last. And that's from 2n squared, the formula. So if n is 1, that would be 2. If n is 2, that would be 2 times 2 is 4 times 2 is 8. And if n is 3, well, that's the maximum. So we have 11 total. So we need 2, 8, 1. And the closest is, choice A. An atom becomes an ion with a charge of +3 if you lose electrons. You lose 3 electrons. D. Ions are always charged. No. That's ridiculous other choices. The atomic mass, this is a straight definition, 1/12 of a carbon-12 atom, 1/12 of 12. How many protons does a boron-11 atom have? It's boron, so it's always 5, which is none of the above. Atomic number is protons, none of the above. Weird. Which was not a conclusion of gold foil experiment. Some alpha particles were, it's got to be B. Yeah, because they didn't figure out neutrons until later. That was James Chadwick. J.J. Thomson's cathode ray experiment determined that atoms have electrons. That's a weird C. And finally, naturally occurring boron consists of 2 isotopes, boron 10 and 11. If the atomic mass of natural boron is 10.8, what is the percentage that's boron 10? So let's see. So atomic mass. Okay, so see how the mass is skewed? So if we've got a 10 and 11, those are our 2 masses. The average is 10.8, which is like here. So it's skewed way more towards the 11 because it's a weighted average. So it's not a 0%. So which is boron 10. So this is low number. So I'm going to go with B. Because if it was a 50%, it would be 10.5. And since we're so close to 11, there's way more that's 11. So it's got to be the lower of the number. If you have any questions, please let me know. Thanks for watching.